Okay, this lesson we are going to start with just earthquakes, and then we will move into volcanoes after we cover earthquakes completely. And I bet right now you're happy that you are completely finished with rocks. Okay, so it says describe what you think it would be like to experience a severe earthquake. What do you think it would feel like? What would it look like? And what would it sound like? Whenever we have class, I'm going to show you some video clips of the first time that an earthquake was actually caught on camera. Oops. Okay, so it says an earthquake is the shaking and trembling that results from a sudden movement in the Earth's crust. Scientists say that there's more than 1 million that occur every year. So that gives you an earthquake every 30 seconds. Most of them are not big, and we actually want those little movements because it's when an area goes a long time without movements that you end up with a big earthquake. The most common cause is going to be faults. A fault, it says, is a break in the Earth's crust where movement occurs. You have to know the definition of a fault. It shows up many times as we move through geology. So let me go back. On here you can see there are two plates. One is moving north and east, and one is moving south and west. The movement that occurs, I'm going to highlight it, right where the two meet is where the earthquake occurs. Okay, so the longer that one is moving in this direction and one is moving in this direction, and they eventually will snap back like a rubber band, that's when you're going to have your big earthquakes. Okay, so the San Andreas Fault is an example, you can see by the arrows, of exactly what I was just showing you. It's a transformational fault. So we have one scraping by in one direction and the other one scraping in a different direction. And this goes all the way from Mexico up to Washington State. We'll watch that video in class. Okay. This just shows you a picture of a fault line. So the damage is going to be the most in the epicenter, and we'll get to what that actually means. It says if you were swimming in the ocean, how would you know a tsunami was coming? Tsunamis are generated by a movement in the crust. Okay, so if there's an earthquake on the bottom of the ocean floor, we end up with a tsunami, and that's the definition of a tsunami. All right, so it doesn't have to be a huge wave. Some tsunamis are small waves, they just look like regular waves. Tsunami just means that it was caused by an earthquake on the seafloor. They can, though, get really big, and we're going to watch some video clips in class of the ones that hit Japan, Indonesia, and we'll look at those. Okay, some vocabulary. This is a lot of vocabulary in this unit. The focus, it says, is the point beneath the Earth's surface where the movement occurred. Okay, so I shortened that, but that's what it means. And then the epicenter is going to be directly above the focus, and it's going to have the most damage. Okay, so this diagram is very commonly seen on the SOL. So you would have to label the focus is here. Directly above it, we have your epicenter. This line is a fault. Okay, so this is it underground, and then this is it above ground. And then you can see these circles. These are your seismic waves. Okay, so the energy coming out from the moment it moved. We will look at that in class. Okay, it says over 90% of earthquakes occur where the plates are colliding at a destructive plate boundary. So this can also happen. So we have one plate that is being subducted or pushed underneath. And so when we look at plate tectonics, we'll go into further the different types of interactions. All right, so seismic waves. It says waves. You should add the word seismic. Here it is right here. Seismic waves are what we call any waves of energy that come from an earthquake. And there are three types. Okay, so the first one that arrives is the P wave, which stands for primary. Primary means first. Okay, so they also travel the fastest. They're longitudinal, which means if we've stretched out a slinky and I moved one side and we saw the energy go all the way across to the other side, that is a longitudinal wave. All it's really going to do is do some shaking. It's usually the first indicator that an earthquake is coming. You might feel shaking. It's not going to be a huge, noticeable thing, but you would definitely feel it. Now the S waves are secondary. It says they arrive secondly. They're also called shear waves. They can only go through solids, so this wouldn't happen in the water. And they travel like an S. So now the land is being pushed up, and so the house gets picked up and set back down. And at this point, things are going to fall. A chimney might break off. Things are going to fall off the walls. Dishes are going to come crashing down. Things like that. The last one, an L wave. This only shows up in the epicenter area. It is the most damaging. They travel like an ocean wave, and there have been people who said that they saw the land moving like a wave from the ocean. You actually see it moving. And what it does is it picks up the house and throws it forward. Think about if the ocean wave hits you, it pushes you forward. So at that point, the house would be completely destroyed. Okay, so shows up last, called L waves. They are the most damaging, and they travel in a circular motion. Okay, so this shows you an example of each one. That one. Okay, so it says earthquakes are the shaking and vibrating of the earth. It's not uncommon for the earth to open all the way up. You can see the openings here, and then it will eventually, not always though, close back again. Sometimes it does just leave this damage. This opening is permanent. All right, more vocabulary. A seismograph is the instrument that you use to detect the severity or how intense the seismic waves are. A seismologist is who studies it. A seismogram is the paper that comes out that they would collect for evidence. And a Richter scale is what we use to determine how severe the earthquake actually was. Right, here's the Richter scale. You don't have to know this by heart. What I want you to know, though, is that each number is 10 times stronger than the one before it. So the difference between a 1 and 3 is actually going to be 100 times. Because a 1 and a 2 is 10 times stronger than a 1. A 3 is going to be 100 times stronger than a 1. And a 4 is going to be 1,000 times stronger. And so each time it's much stronger. It's 10 times stronger than the one before it. In this picture over here, it shows a 3. You got the shaking. He knew something was happening, but it's not as bad as when you get to the 6. Now the chimney is falling off. And then 9, the whole house would fall down. It would be total destruction. All right, so can we predict earthquakes? Not really. They have found some certain things that tell you it's going to happen, but only seconds before, so it's really not enough time to warn people. A change in the P and S waves, so we do have seismologists who are always watching what's going on inside of the earth, monitoring the movement, and when they see a change, they know an earthquake's going to happen, but it's only seconds before. If the land suddenly tilts, if your well is pouring out water and it wasn't before, that could indicate that it's about to happen. And also animals, their intuition is usually better than ours, and they know. They'll start moving away from the area, knowing it's going to happen. All right, so in this picture we see, again, here's your focus. Directly above it's going to be the epicenter. You have a fault underground, above ground, then you have your seismic waves. In this top picture on the right, it shows P waves. The bottom on the right is going to show you S waves. I'm just going to flip to label everything so you can see. Okay, and this shows an earthquake-proof house. The things that we know we try to do in areas that are prone to earthquakes to make it safer. So it says plywood is nailed to the ceiling joist, and plywood can move. It's bendable. Okay, so it's not going to break if it gets moved. Metal brackets holding the chimney on. A frame is bolted to the foundation so that if the foundation moves, the house moves with it. The water heater is strapped to the wall. So these are just several things. Okay, so it says, notice the closest major risk to Virginia. It's actually Charleston. And they haven't had a major earthquake in a long time. So scientists, because the longer it takes for them to have a good-sized earthquake, the more severe it's going to be. And so they actually predict, and we'll see if it's right or not, but they predict that And they finally do have one that would be felt all the way up to New York. Hopefully that's not true, but we will see. Do you think it's possible to create something that can withstand the worst earthquake? What materials would you use? How would you build it? This is where our STEM lab's going to be going. Something to think about. We're not going to go into volcanoes. We're actually going to stop there. We're also going to do a virtual lab where you understand how to figure out where the epicenter is. And we'll be doing all that in class. Okay? See you on Tuesday.